These are notes for Algebra 1, 4.11, Graphing Solutions of Systems of Inequalities. This is day 2. So we're going to use the situation below to answer questions 1 through 3. So it says, Mrs. Bailey is hosting a party for her friends. She is making her famous fruit salad. Mrs. Bailey knows she can spend less than $10 buying grapes and apples for the salad. Grapes cost $2.50 per pound, and apples cost $1 per pound. She needs at least 4 pounds of grapes and apples to make the salad. How many pounds of grapes and apples can she buy? Okay, so we're going to have to set up an equation, so we always do that using let statements. So we're going to let, and we're going to have x and y. So let x equal, let's let x equal the grapes and y equal the apples. Now there's two things we got going on in this problem. We have the amount of money she can spend. She says she has to spend less than $10. But she wants to get at least 4 pounds of grapes and apples. At least means greater than or equal to. So let's do our two equations. So it says write an inequality that represents the cost of the fruit. So remember, we're going to have to look at the cost. So $2.50 times the grapes, which is x, plus $1 times y, which is the apples, needs to be less than $10. Then it says write an inequality that represents the pounds of fruit that Mrs. Bailey will buy. Well, if x is the total amount of grapes and y is the total amount of apples, x plus y needs to be greater than or equal to 4. And that's what we would use to set up our inequalities. Now, they didn't ask us to do this in the problem, but if we wanted to graph these inequalities, we would have to solve both of these for y, and then we could graph them. So on this one, all we had to do was set up the inequalities. We didn't need to graph them. But if you wanted to graph them, you'd have to subtract x on this one, and on this one, we would have to subtract 250x and then divide everything by 1. So we're just going to leave it at that for now, and now we're going to go on to question 4. Okay, so number 4, it says state which points are solutions to the system of inequalities that are graphed. So let's do as a reminder from yesterday, how do we know what the solutions are? The solutions are going to be in the area of the graph that's been double shaded. Also, on solid lines, you have solutions. On dotted lines, no solutions. And on an intersection, they both have to be solid lines to be a solution. So one solid and one dotted would be no solution on the intersection point. Okay, so let's take a look at these. In fact, why don't you try those without me? Hit pause and decide yes or no, are they solutions or not solutions. And what I would do is go ahead and plot the points on the graph. That'll be the easiest way for you to tell. So plot the points and then say yes or no. Okay, so I've gone ahead and plotted the points. So here's point A right here. It's on a solid line, but it's not in the double shaded area, so that one is no. Not a solution. If it was on the solid line up here or down here where we're in the shaded region, it would be good, but that one is not. It's only in half shaded. So 2, 2, which is B, is in the shaded region on the solid line, so that's a yes. Negative 1, 4, which is C, it's only in half shaded, so that's a no. 4, 1 is D, and it's in the double shaded area, so that's yes. And then negative 3.5, negative 1.5, it's not in anything, so that's a no. Okay, now it says, is negative 3, this is number 5, is negative 3 comma 6 a solution to this system of inequalities, yes or no? And it says to show your work. So what we're going to do here is we're going to plug in the x and the y, and we're going to see if it works for both equations, or both inequalities. 3y is greater than or equal to negative 6x minus 9, and then 6 is less than or equal to 3x plus y. So let's go ahead and plug in. So we have 3, and instead of y, we're going to put in a 6 for y is greater than or equal to negative 6, and instead of x, we're going to put in negative 3 minus 9. So all I did was substitute the x's and the y's. So let's go ahead and solve this. 3 times 6 is 18, greater than or equal to. So let's see, negative 6 times negative 3 is positive 18 minus 9. So we have 18 is greater than or equal to 9. Is the number 18 greater than or equal to 9? Yes, it is. It's greater than 9. So that one works. Now let's try this other one. 6 is less than or equal to 3, and instead of x, we're going to put negative 3 plus y, which is 6. So let's look here. We have 6 is less than or equal to, and we have 3 times negative 3 is negative 9 plus 6. So we have 6 is less than or equal to, negative 9 plus 6 is negative 3. So does that work? Is 6 less than negative 3? No, that does not work. So no, it's not a solution. This number is not a solution for that system of inequalities. Okay, so this next question says to write a system of inequalities for the graphs below. So it's like a little puzzle. We've got to figure out what the inequalities are. So just like on equations, we're going to need to figure out what's the slope, the rise over run, and what's the y-intercept. But then the other part of the puzzle is figuring out where the shade is. Is it above? Is it below? Is it a dotted line? Is it a solid line? And we're going to figure out what the inequalities are. So let's start with this first picture on number 6. So first of all, it says inequality A. So here is A right here. And we've got lots of pretty points on this one because the slope appears to be 1 over 1, 1 over 1, 1 over 1. So it has a slope, we'll write it over here, A has a slope of 1. And let's look, here's the y-intercept right here. So the y-intercept is 1 as well. Now, let's take a look at line A. So we can see that line A, the shade is above the line. Now, how do I know that the shade is above the line on A? Because here's the shade. If the shade were below the line on this one, this white area that's right here would be shaded in. Okay, so we can tell that the shade is above the line. So if it's above the line, it needs to have a greater than sign. And it's a solid line, so it's going to be greater than or equal to. So we can go ahead and write our inequality. Y is greater than or equal to 1x, and we'll just put the x like that, plus 1. Now let's look at the second inequality, which is line B. Okay, here's line B. So we can see it's a horizontal line, so that's a Hoy line. Hoy lines always have the same kind of equation, and here's the clue. It's always going to be y equals something. So let's look. It's crossing through the 3, and it's a dotted line, and we can see that the shade is below the line. The reason I know the shade is not above the line is because if it was above the line, this little white area right here would be shaded in, and it's not. So that solves our little clue. Whoops. So So let's look here. Let's go ahead and write our inequality. So we have a Hoy line, so we know it's going to be y equals, and we have to figure out what sign. It's below the line, so that's less than, and it's dotted, so we know it's going to be less than. So y is less than 3. And that's it. There's your equation, or inequality. Let's try number 7. Okay, so first we'll do letter A. So we want to find the slope, and we want to find the y-intercept. So if we look at the slope, we want to find 2 pretty points, and we can see the rise over run looks like 2 over 1. 2 over 1. 2 over 1. I'm not drawing those very well. So A, we'll write it over here. A has a slope of 2, and let's find the y-intercept is down here. So there's the y-intercept right there. So the y-intercept appears to be -3. And we can see this one's shaded above the line. How do I know that? Because if it was below the line, this white area would be shaded in. So it's above the line, which means a greater than, and it's dotted, so there's going to be no equal to sign on there. So let's write our inequality. We're going to say y is greater than 2x minus 3. And so we've solved that part of the puzzle. Now let's look at line B. I'm going to erase what we've got here. So on line B, we want to find the slope. And so if we do rise over run on some pretty points, we can see it's 1 over 1, 1 over 1, 1 over 1 negative. So on line B, we have a slope of -1, and then we have a y-intercept up here of +3. Now let's look at that line. It's shaded above the line also. The reason I know it's shaded above, because if I went below the line, it would be in this white area right here. So we know it's not below the line, and it's a solid line. So it's above the line, which is greater than, and it's solid, so it's equal to. So we're going to write our equation. Y is greater than or equal to -x plus 3. And bam, we got it done. Okay, so let's look at number 8. Julie is analyzing a system of equations where both equations are parallel. She is comparing it to a system of inequalities where both inequalities are parallel. She tells her friend that a system of equations of parallel lines has no solution. So this must also be true for a system of inequalities where both lines are parallel. Is Julie correct? And explain your reasoning. So we've got 4 graphs here, and we're going to look at this 4 different ways. First of all, we're just going to look at a system of equations that's parallel. Now, I'm not going to be completely precise about this. We're just going to look at the picture. So remember, if a system of equations that's parallel, let's draw a line, and let's draw a line that's parallel to it. You can put it anywhere on the graph. Now, what do we know about system of equations? How many solutions are there? There's no solutions, because those 2 lines are never going to intersect. But now let's try different inequalities that are parallel. So I'm going to start with one. We'll look at 2 lines that look similar to the ones I just drew. Here's the first line. And let's say that on this inequality, the y's are greater than the line, so we want to shade above the line. So if I shade above the line, there it is. Now on the second line that's parallel, let's say y is less than or equal to that one. So if it's less than or equal to, we'll shade below the line. So are there solutions? Remember, for inequalities, they have to be doubly shaded. So on this one, there's no solutions because there's nowhere on this graph where the shading is ever going to overlap. We're going to have this blank space in here the whole time. So no solutions. But let's try it a different way. Let's say on our first line, we have y is greater than, so we're going to put the shading above it. Now let's do the second line, and let's say y is greater than on this one. Well, on this one we would do the shading above it. So when I shade above, on this one, this area in here, not solutions, but this part up here, it does have solutions because it's doubly shaded. So there are solutions to that inequality. Now let's try it one other way. Let's say on our two lines, here's our first line, and here's the second one. Let's say on both of them, it's less than for both. So if it was less than for both, this one would be shaded below, and this one would be shaded below. I'm going to do it in black. This one would be shaded below. And so this middle section here, not solutions because it's not doubly shaded. But this part down here is doubly shaded, so it does have solutions. So, in answer to the question about Julie telling her friends that a system of inequalities has no solutions, well, it's true if it looks like this, where one of them is greater and the other one's less. But if they're both greater than, eventually they're going to overlap. And if they're both less than, they're both going to overlap. So in this situation, there would be solutions. Okay, so there you go. That's your lesson for Day 2, Systems of Inequalities. And we'll see you in class. Bye.